Hello, everyone. My name is Alexis Casas, and I will be your moderator for this session. Welcome. We're doing this session live, and this session will be recorded. This talk is entitled The Motion Picture Industry and Open Source Software, GStreamer as an Alternative. This year, we wanted to jury our content as DigiPro does, and this talk was one of our submissions. So we want to encourage the pipeline community to submit their ideas for talks next year. Our speaker today is Thibault Saunier. Thibault is a principal engineer working at Igalia. He has been a consultant for the last decade, working around the open source GStreamer multimedia framework, helping a variety of companies leverage the technology in different industries. He is the lead developer and maintainer of the GStreamer editing services, the component implementing support for video editing and post-production use cases in GStreamer. Please welcome Thibault Saunier. Thibault.
Hi, everyone. So I am Thibault Saunier, and today I'm going to talk about GStreamer in the post-production industry. So who am I? Alexis already introduced me, but I am a software engineer working at Igalia. It's a consultancy company working on open source software and many technologies, in particular on web engines, but also on GStreamer, which is a multimedia framework on which I've been working for the last decade. I am the lead developer of the GStreamer editing services. I am the maintainer of it, and I also maintain the PTV video editing application, which is an open source video editing software. I am also maintaining the GStreamer the Python bindings for GStreamer and a few other components. So what this talk is about, it's about presenting GStreamer so that the pipeline community and the film production community knows about it, making sure that you know what it can be used for, what kind of problems it can be used to solve, and I want to also explain why it is used already and how big and mature the framework is. So let's start with what is GStreamer. So GStreamer is a flexible multimedia framework. I'm going to assume that you have heard of it, but you are not that familiar with the technology. And so I'm going to define the characteristic of it. So it's open source LGPL, so you can actually implement applications that are proprietary or plugins that are proprietary, and there is no problem with that. It's cross-platform. It supports all the major platforms, so Windows, iOS, OS X, Android, and it's installed by default on Linux distribution. So it's really the multimedia framework that is used by default on all desktop Linux. It provides a stable C API and API, meaning that we guarantee that anything that you write today is going to be usable with the version that we will have in a few years. We have released 1.0 in 2012, and since then we have kept compatibility with all the code that was produced at that time. So that's pretty interesting. We implement bindings for all the API, and we have Python bindings that are official and that very solid, mature. Many applications are written in Python, and I know that in the film production industry, it's really it's a language that you are very familiar with. We also provide Rust bindings. It's a new set of bindings for the new language that is getting trendy, and it's basically the future of GStreamer is probably in Rust. So it's something that we care a lot about, and that is moving really fast, and we are growing the community around those bindings. And then we have bindings for C#, for .NET, for Java, for Go, many languages. It's quite simple to implement new bindings for GStreamer. I'm going to present a bit the architecture of GStreamer. So GStreamer provides a thing called framework that provides all the concepts that are being used by the different plugins that use GStreamer. We have different set of plugins with different quality and maturity. So first we have the GStreamer plugin base, which will introduce the notion of multimedia, because the core framework is really about basically data processing. And then we have the good set of plugins, which is mature and provides many functionalities and many elements. And then we have the ugly, which are also good quality with good level of documentation, but might have issues with licensing and patents. And then we also provide a set of tools that can be used to either prototypes your application. So GStLaunch, which basically provide a command line interface to run a GStreamer pipeline. I will explain in a bit what the pipeline is, how it works, etc. And then we have, for example, the GSLaunch application, which is a tool to create and run a timeline. So insert files from one time to another with an endpoint and things like that. So basically timeline description in the command line, and then you can render it, play it to whatever you want. And then we have many third-party applications and web services and servers for all kinds of multimedia applications, either proprietary or open source. And then we have third-party plugins that implement all the functionalities that those needs. So GStreamer is very plugin-centric, so that we just have that core framework, and then we have a lot of plugins that are built on top of it. And we have officially over 250 plugins, and that provide 1,700 elements, but even more than that. And then we have many, many third-party plugins and elements that I could not count. So it's the design of GStreamer is what we call pipeline-based. I guess you are familiar with the notion of pipeline here. So here it's really a pipeline for data processing. So in that case, I'm just showing you a simple player pipeline, which will basically read a file on disk and then pass the data to the next element, which in that case is a log demuxer. That demuxer will just process the data and expose what we call pads. So a pad is where two elements are linked together. So here you can see that the OG demuxer elements has two source pads, one for the audio stream, one for the video stream, and then in those pads will flow the data, which are inside buffers, and in the buffer, and they go from one element to the other. So then you can plug any filter you want. You can do all the processing you want with just like those little elements that you put together to build the application you need. We have many kind of elements that can, for example, instead of having to plug your own demuxer, your own decoder, etc., we have elements that will do it automatically and dynamically. So this is the kind of things that we do for non-linear editing, but it's also what we do all the time just for playback. So we just discover the stream and then we just plug the elements. And you don't have to do it as an application. We have all the higher level APIs and higher level elements that will just do it for you. So you just say, I want to decode that stream and give me the result of that. And we have all the services for this kind of application. So what is not, it's not a monolithic multimedia library. So in comparison with, for example, FFmpeg, where you have a set of small libraries that do things, we are more like modular, where we have that notion of plugins where you can, and then you can build a pipeline with just those little elements, putting them together. So it's really a toolbox where you can implement your own tools in your own site and build them separately. So a GStreamer plugin is just a shared library that you can build on your site and just put it in the right place, and then GStreamer can reuse all those functionalities that you are implementing. It's not a player, it's not a streaming or rendering server, or it's not a video editing tool, but we have built all those kind of applications on top of GStreamer. And we provide high-level libraries that allows you to implement those kind of things in a simpler way. For example, for video editing, we have the GStreamer Editing Services library that provides the notion that you need for that. For rendering server or streaming server, we have GStreamer Transcoder, which also is a library that we just provide higher level APIs for that, so you can script it and do what you need with it in a simpler way than have to plug the elements yourself. And then we have, for example, GST Player, which is an API to build a player on top. Where is it currently used? It's used in many industries, and one of them is in web engines. So, for example, in WebKit GTK or WP, we have GStreamer as the core multimedia engines. So all the multimedia needs of the web engine are implemented with GStreamer. Servo is also a web engine from Mozilla, where they also use GStreamer for all the multimedia needs, so all the video decoding, the video processing, for example, for live conferences also, you have GStreamer that also implement that. Then you have GStreamer. The web inside GStreamer, for example, we have elements that wraps WebKit so that you can have a web page inside GStreamer rendered as a source. And then you have GStreamer RTC, which implement basically video conferencing. It's just inside GStreamer, the same protocol that is used in web engines and on the web platform. It's used in many embedded devices, so many set-top boxes of many different companies use GStreamer at the powering the multimedia needs. Then we have many low-powered embedded devices. So, for example, Tizen, the Samsung operating system, uses GStreamer for all multimedia processing. So, in your TVs, most probably you have GStreamer running for all the multimedia processing needs. Same thing for smartwatches from Samsung, which are also based on Tizen, and some phones that use Tizen, but not on Android. And then LG is the same thing. They are actually basing most of the multimedia stack on top of GStreamer. Then in many integrated entertainment systems, like in-flight entertainment, in-vehicle infotainment, these kind of services, there are many companies that are building all those kind of multimedia application with the framework. And then we have video walls that have been implemented on top of GStreamer. This kind of use cases is quite interesting in the sense that it requires really high precision in terms of synchronization between the different devices. So GStreamer has all the synchronization needs of audio and video synchronization in all the use cases that we have. So we have all the infrastructure for this kind of problematics integrated inside the core framework. So we're able to have very precise synchronization. In that case, between the devices, and in the usual case, and in what matters to you between audio and video. So there's that. I'm going to give other examples where it's used, like video security systems. There are many companies building video security systems that are inside control rooms, and the cameras all use GStreamer basically for the processing. Augmented reality platforms, some drones are using it for streaming services, etc. In industrial image processing also, there are many industrial companies that use GStreamer basically for video analytics. And then we have many web services that use GStreamer, for example, for video conferencing or this kind of services, or rendering, etc. So then we have recently had many frameworks that have been based on GStreamer for deep learning. So, for example, nvidia has based its DeepStream SDK and framework on top of GStreamer. It's basically NVIDIA's AI framework. So GStreamer is like at the core of the framework. It exposes the APIs directly. So you have GStreamer exposed right inside their own framework. So the multimedia processing is done by GStreamer, and then they expose their own APIs for all the neural network needs. And Samsung is actually doing the same thing with NNStreamer, where GStreamer is also like core component of the APIs that they expose for deep learning. And as a community, we're also working on GStreamer Inference, which basically is a set of GStreamer plugins to allow reusing other deep learning frameworks with GStreamer. We also have ingest and playout servers that are all based on GStreamer. So that kind of things required live recording, compositing live, probably hardware-based compositing, and then broadcasting. And these kind of services need real extreme reliability. So it has to be available all the time and be reliable, extremely reliable. And then, as I already talked about a bit, we have video editing software. So in that case, I'm showing off PTD, which is a video editing application. That is basically just a UI on top of the GStreamer editing services. It's less than 50,000 line of code, Python. So that shows that, yeah, we are very used to working with Python also. And this application is still missing a few features, but it's evolving very, very quickly. And we have many Google Summer of Code students working on it this year again. And it's quite, it's evolving pretty fast. So GStreamer in the filmmaking industry, we have, as a community, we have started almost since the beginning to build the components that are needed for nonlinear editing. So Nonlin, the GStreamer set of elements that powers nonlinear features, has been built in 2002, and since then it has kept evolving and maturing. Many people have worked on it, and since GStreamer has been built since the beginning design to integrate with existing tools, it is for sure quite easy to integrate with the pipelines that you are building in the film making industry. So I just wanted to make sure that you know that we have all the infrastructure in place to integrate with GPUs. So we have libraries to integrate with OpenGL, Vulkan, Jake3D, and CUDA, for example, so that you don't really care about where the frames are. You can just pass them into the pipeline with the right kind of pipeline, and GStreamer is able to negotiate the kind of memory that you want to work with, and you have to work with depending on the elements, and then the processing can be done wherever it's more efficient and wherever you want. GStreamer already supports a number of formats that are used in the post-production industry. So OpenEXR, which is the must-have in your case, ProRes, MXF, and these kind of things are already used in many places and in production. We are probably missing OpenColor.io, which is something I've started working on. So yeah, it's one of the things that are still missing, but it's the kind of things that we have been doing, like integrating this kind of technology. We have been doing it for decades now, and we can for sure solve that. And then, as I talked a bit about GStreamer services, it's the API that you would use for nonlinear editing with GStreamer. It introduces quite high levels APIs for video editing. So you have the notions that you are familiar with, like timelines, projects, layer. And we have a certain level of asset management control. And that has been designed to be integrated in your own asset management system. So that GStreamer editing services that's been used in a few applications that you have probably come across in the past. And some studios have already started looking at it. It's not really used yet, but I hope that you understand how we can help you solve your problems. We have integrated the GStreamer with OpenTimeline.io. So OpenTimeline.io is an interchangeable format to facilitate collaboration, communication of editorial data and timeline information between software and studios, etc. So we have implemented an adapter inside OpenTimeline.io for the XGS format, which is the timeline serialization format from the GStreamer services. And that project is part of the ASWF group. It is actually integrated inside GStreamer, so it's both ways. It's like a first-class citizen inside GStreamer. So any format that is handled by OpenTimeline can be used as if it was a multimedia file. Yeah, you have all those tools inside GStreamer, and you can reuse them the way you want and build any software that you want and to solve use cases that you have in mind. I hope that helps you understand what GStreamer is, what it can do for you, and thanks in advance. And do you have any questions?
Okay, thank you, Thibault. We have here today Rob Blau with us, who is going to help us and get questions from the audience. I have to admit, Thibault, that when we received your submission, seeing the name GStreamer was really surprising for me. Until now, over the past for many years, for me, GStreamer was something whenever I installed a new Ubuntu distro and I wanted to listen to MP3s, I had this weird plugin that says, yes, install. And you told me when we touched base earlier that you've been working and integrating OpenTimeline.io, and through the Academy Software Foundation, you heard about the Pipeline conference, and you decided to submit to this conference because you wanted to reach out to the Pipeline community. Could you tell us a little bit, like, have you ever approached studios before, or have they approached you? Because over all the pipelines that I've been working on, I've never seen GStreamer being used in a visual effects or animation pipeline, and it never occurred to me that I could use it.
Right. So I have had conversation with some studios. For example, a while ago, I've started making some state-of-the-art work for DreamWorks for special application, which were basically a reviewing system for video editing projects. So we have had some discussion in the past. I think GStreamer hasn't been used much, and people don't really know in the industry what it can do and how it works, etc. You don't have the experience of that technology, and you don't really have a good overview of all that it can do and what kind of applications you can build on top of it. So yeah, that was the idea of that talk, is like to let you know that this exists. It can do a lot of things. There are many people using it in many other industries, and I'm pretty much sure that we can work together to build new applications and build and solve the issues that you have in your industry, integrating it in your pipelines, basically. Okay.
Do we have any questions from the audience, Rob?
Yeah, let me dive in. Thibault, great talk. That was fascinating. And I had a list of 15 of my own questions, and I just kept checking them off as you kept going. You kind of answered a whole lot of questions that I had. So from the audience, the first question here is, if you know what the VFX reference platform is in terms of kind of the required versions for common libraries used across a lot of the open source projects and even commercial applications in VFX, is GStreamer compatible, or could it be made compatible with the reference platform?
Oh yeah, it can definitely be. I'm pretty much sure it already is. Basically, I mean, it's still running on CentOS 6, even master from now. So you can work on any Linux distribution from prehistory until now with even GStreamer master. So I don't doubt that we can make it compatible.
Okay, excellent.
If it's, I mean, it's probably already, but if it's not, it will be simple to make it.
Okay. Everybody, I'm sure, is happy to hear that. The next question is, you mentioned iOS. Does GStreamer have a license exception that allows its use in the App Store? The user replacement clause usually disallows something like that.
There is no problem for GStreamer itself. I know there are applications using GStreamer that are in the store. I think there are a few cases where they don't allow you to replace things, but for that particular case, we just reuse, for example, for multimedia, for decoding, etc. We just reuse the components that are offered by the OS. So it's just a library on top of that. It's not a replacement. For example, you cannot replace the web engine or things like that. But for our case, I have never heard of anyone having any issues pushing the application on the store.
Oh, interesting. And I think, I mean, given the formats you were talking about, there's an implied answer to this one, but are you able to use individual files as video source? And specifically, how suitable would GStreamer be for treating a set of individual image files as a video source? Do plugins exist that will deal with preloading files to allow smooth playback and nonlinear scrubbing?
Yes, we have that. We have basically a GStreamer multifile source or multi-image source. We have two elements that allows you to just say, okay, read those files that are over there and play them as if it was a video stream. So yeah, we have that.
Okay. How are color spaces and look transforms handled? You mentioned that you're working on OpenColor.io now. Can it be used with ACE's working space? The ACES color space standard?
We have the ACES. I'm not sure. I've never worked with it specifically. We have Bayer format support. We have usual raw format support. So basically, it's just a matter of having the elements that understand the formats. So basically, inside GStreamer, you will have the data that is described by tabs, capabilities, and then the elements will negotiate the format inside between them. So you have a mechanism that allows you to negotiate what kind of data you can handle. And if you have a set of elements that handle ACES, we'll just negotiate that format and work with that. So, yeah.
Okay. Does GStreamer handle reading concurrently multiple live media sources? For example, if you wanted to compose a collage of webcam.
Yeah, sure. There are many services that actually use that. Yeah, you can have any sources, composite them together. We have two modes inside GStreamer for elements processing. We have a live mode and a non-live mode where the scheduling is very different if you are in one mode or the other. But yeah, your pipeline, in that case, your pipeline will be scheduled as live and everything will try to be like on time, respecting a certain latency that you basically set.
Cool. Someone more technical than I am is asking the next one. How does GStreamer deal with demux versus decode in pframe codecs? Do demuxer plugins return packets in GOP units?
So basically, you will have the demuxer that will just like after a seek, I guess, or something like that. It will just like find the last intra frame, push that, and then we will have parsers, which is used to for H.264, for example, it will just like what we call frame packets, so that the following elements will receive one frame per buffer. And then, so yeah, we will decouple that into the demuxer. Then you have the parser for a specific codec format, and then you have the decoder that is after that. Hoping it answers the question.
All right. And the last of our current questions from the audience. So if anyone has any more, just pop it over into the session Q&A. Does GStreamer have, or could it have, a virtual decklink device input driver that would make it work as a streaming output for standard apps?
Yeah, we have a decklink plugins. Many people use that in production and different kind of applications.
Very, very cool. And that is it for the audience questions right now.
Okay.
Thank you very much.
So if we don't have any more questions for Thibault, I do really hope that this presentation today will encourage different studios to adopt the GStreamer framework in their pipelines. Our next session is at 1 p.m. Pacific Daytime, and it will be up really shortly. You should be able to join directly through the agenda on Whova by clicking on session. The next talk is a DigiPro talk, and it's about taking OpenColor.io to the next level. So OpenColor.io is a project hosted at the Academy Software Foundation, and it will be about all the new features of OpenColor.io version 2. The speakers are Doug Walker, tech lead in color science, and Patrick Hodul, principal software dev, both from Autodesk, and Michael Dolan, senior pipeline developer at Epic Games. Thank you all, and see you later today at the reception at 3 p.m. Pacific Daytime. Thank you.
Thanks, everyone.
Thank you.